So we're continuing with Lesson 17, starting at our Try It section. We want to use what you just learned about inequalities to solve these problems. In number 7 it says, students in the garden club are planting a spring flower garden in the town square. They have already spent $80 of the $200 budget. Write and solve an inequality to show how many $30 packs of bulbs they can buy. We know that the first thing we need to do is read those words. Then we should highlight, circle, or underline anything that we found to be important. So what's important in this problem is the fact that they have already spent $80, and that came from a $200 budget. We want to write and solve an inequality, and we want it to show how many $30 packs of bulbs they can buy. So as we're looking through this information and we're taking into account that they have a $200 budget, what inequality symbol does that let us know we should use? Less than or equal to, because you can't spend more than what you have. So we're going to have what we have already spent in our problem, and we will add that to what we want to pay on packs of bulbs. And what we spend on those two items needs to be less than or equal to our budget. Again, this is making sense of the problem and creating an inequality statement. Now we have already spent how much money?
$80.
And on bulbs, we are going to spend what?
$30.
$30 for every pack. So 30x or 30p, either is fine. And that needs to be less than or equal to our budget, which is $200. Now we're going to solve the inequality that we have, meaning we'll subtract 80 from both sides, leaving us with 30p is less than or equal to 120. We will then divide by the amount it is per pack, meaning that we could have 4 or less packs of bulbs. Then we want to draw a number line and graph the solution set. So when we talk about the solution set, could you have a fraction of a pack of bulbs that you buy?
No.
Could you have a negative amount of packs of bulbs that you buy?
No.
So our number line will contain the numbers included in our solution set. We could have 4, we could have 3, we could have 2, we could have 1, and we could have 0. So we use a closed dot on each one of those whole numbers. Okay, in our next problem, we are now looking at setting up a multi-step inequality. So we know that if it's a multi-step inequality, it's going to contain more than just the two steps in order to be solved. So let's start by reading the problem. Mrs. Sanchez is building a laundry room in the basement of the apartment building she owns. Given the layout of the basement, she wants the width of the room to be 20 feet and the length to be longer than the width. If she wants the area of the room to be more than 500 square feet, what could be the length? We want to look at the diagram that Mrs. Sanchez drew. Now that we've read the problem, we need to go back and circle, highlight, or underline anything important. And what's important in this problem is that she wants the width of the room to be 20 feet and the length to be longer than the width, and she wants the area to be more than 500 square feet. So overall, we're looking for what could be the length. How are we going to find an area?
You're going to multiply all the sides.
Are you going to multiply all of the sides? We're going to multiply the length times the width. And when we do that, we want that to give us a number that is more than 500. So what inequality symbol should we use?
Greater than or greater than.
Well, if it's going to be more, it needs to be greater than, but could it be equal to?
No, because it's got to be greater. It has to be.
No, because it says it has to be more, so more would be greater than. If you look at the next section, it says to model it. And by modeling it, it's wanting you to create the inequality statement based on the words. So it's telling you that the product of the width and length must be greater than 500 square feet. That's telling you about area. So area or multiplication is commutative. So you could multiply the width times the length or the length times the width. The reason why they've chosen width times length is because 20 times 20 plus x represents what property? Distributive property. And we want that to be more than or greater than our area of 500 feet. So now, when we go through and solve this problem, we'll distribute 20 to 20 and 20 to x, leaving us with 400 plus 20x. And that needs to be greater than 500. We then would subtract 400 from both sides, leaving us with 20x is greater than 100. We would divide by 20. Our 20 is positive, so our symbol stays the same, meaning that x will be greater than 5. And what we're saying is x needs to be greater than 5 feet. So what numbers are greater than 5? 6, 7, okay. Could you have fractions? Yes. Could you have decimals? Yes. So if our x value needs to be greater than 5, it could be 5.5, it could be 6, it could be 6.5. It could be any number that is larger than 5. And what that means in relation to the length of the wall is that the length of the wall, in order to give you an area of more than 500, must be greater than 25 feet. So that's how you're using the information in the context of the problem. The next thing we're going to look at is modeling this on a number line. And again, when you model this on a number line, you have to make sense of the context of the problem. And in this problem, the numbers in the solution can be whole numbers, they could be decimals, or they could be fractions. So you can measure to a fraction of a foot or inch, and that measurement could be used to solve the problem. So the graph shows a solid line. This is where we represent our open circle, meaning it can't be 5, but with our solid line pointing to the right with an arrow, meaning that our answer could be anything greater than 5. Now let's make some connections about what we just covered with our two modeling situations. We want to look at the solution and the graph to analyze and interpret the inequality. If we first want to describe in words what the inequality statement in the first model means, that is stating that when you take the length and the width and you multiply them together, so length times width, which is area, we need to have a value that is greater than 500. So length times width needs to be larger than 500. Then it asks you, what do you do with any value for x in the solution set to find the length? So we know that if x can be any number greater than 5, if it were 6, we would take it and we would add it to the width because we need to be more than the width. So any value for x gets added to 20 to give us the value of the length. Now that we've made sense of what was happening in the context of the problem, we want to look at the graph of the solution set. Why is there an open circle on 5? What does it mean if we have an open circle?
It's just less than or greater. It's not equal.
It's not equal to 5, so that means that 5 cannot be a value for x. Then we're going to answer the question, why is there a solid line instead of just circles on the whole numbers? The fact that we have a solid line means that any number that is greater than 5, including decimals, including fractions, can be a value for x. So the line represents any number that falls between the whole numbers. Number 12, it says, the numbers on the number line end at 8. The arrow shows that the numbers beyond 8 are also in the solution set. Given the problem situation, do you think the solution set could extend forever, or will there be a limit? And explain. So answering the question here, the context of the problem talks about the length of a room. It does not make sense that the length of a room can extend on forever. So there will probably be a limit, but we don't know what that limit is. Alright, so the next question says, in words, describe what the solution set is and what it means in the context of the problem. So our solution set is any number greater than 5. And with the context of the problem, that means that the length of our wall will have to be greater than 25 feet. So now we're going to try a problem, and basically we're taking the information that we know about solving multi-step inequalities and proving that we can solve one even when we're not given context of the problem. So we want to use what you just learned about inequalities to solve this problem. Show your work on a separate sheet of paper, but you're welcome to write in your book. We want to solve 8 times 12 minus 1/4 x is greater than or equal to 82. And then we want to graph the solution set on a number line. So we would start with the distributive property. 8 times 12 is going to give us 96. And 8 times negative 1/4 x is going to give us negative 2x. And that's going to be greater than or equal to 82. So now we will remove the 96 by subtracting our constant. We'll subtract it on both sides, which leaves us with negative 2x is greater than or equal to negative 14. We will now divide by a negative 2, and we know that with inequalities we have to pay close attention to division. And the fact that here we are dividing by a negative number means that we must turn our inequality symbol around because our relationship has changed. That leaves us with x is less than or equal to positive 7, because negative 14 divided by negative 2 is positive 7. So now, because we don't have any context in this problem, our graph will look like any other graph that we've created, where we're centered around the number 7, because that's what we solved for. The numbers above 7 might be 8 and 9. Numbers below might be 6 and 5. Because we're less than or equal to 7, we would have a closed circle at 7. And then we would continue our arrow in the direction of the numbers that are less than 7. So, to the left.